Hello everyone, my name is Lebu and I'll be going through November 2018 paper 1 for maths, and question 1 starts with solve for x. So the first question we have is the basic or straightforward quadratic formula. So as a reminder, remember that this is the general formula for quadratic formula. So we have y is equals to ax squared plus bx squared plus c, where c is our x-intercept. So when you come back here, when they say solve for x, what they mean is solve for the x-intercepts on our equation. So to solve for x-intercept, you let y be 0. Hence, you have to make sure that on your right-hand side, or on one side of the equation, you always have 0. So you can't solve anything yet if you don't have a 0 on one side. So let's say you have any other terms this side. It might be x, it might be a number. So in that case, you're going to have to transpose them and then add them so that you only have 0 left on this side. And then now, luckily our equation was more simpler, so we didn't have to do any transposing. So the next step is to factorize. When you factorize, that's where you open the brackets and then find the factors, so that when you multiply these two factors, you'll go back to that equation or the original equation. So in this case, to find the factors, we had to find, we just did like simple x and then exercise. So that when you multiply them back, you find x squared. And then to find the last terms on each bracket, we look at the last term here. So what are the terms, or what are the factors rather, of 3, so that when you multiply them back, you get 3 again. So the factors of 3 are 3 and 1. There are no others. So when you multiply them, you'll get, so it's 3 multiplied by 1, you get 3. But then now the issue is with the signs. So with the signs, you have to make sure that when you multiply everything else, you have to get this value here, -4. So the way I normally do it is to make sure that, I get that, but this one you don't need to, x, so yeah, on one bracket you have 3, on the other you have 1. So what we're looking for is that when you multiply this, you'll get 3x. When you multiply that, you'll have x. So what we're looking for in the middle is so that when you add or minus this 2, you'll get negative 4x. So what we do, because now we have 3x and x, so they should both be negative. So for them to be both negative, if they're both negative, you're gonna get a negative 4x. So that means when you multiply x by -3, you get negative 3x. And then when we do cross multiplication here, so when you multiply here, you also get negative x. So that means both brackets have negative as their sign there. So that is why we have that. So even if you were to go back, you should be able to get to this formula. So the trick, because this one is basic, so what you need to find the signs here is to make sure that when you when you add or minus, you get the value there, like I did here. So yeah, and then from there, once you have the factors in individual brackets, you equate each bracket to 0. And then, so here we have x minus 3 is equals to 0, or x minus 1 is equals to 0. And then from there is simple transposing as well, because we're looking for x, not x minus 3, or not x minus 1. So to transpose, our final answer becomes 3, and then another answer becomes 1. Excuse me there. And the next question, so this one, in the question paper, they normally write in brackets, round off to, let me see, 2 or 3. Where is it? Round off to 2 decimal places. So once they say round off to 2 decimal places, don't crack your head thinking like, okay, how am I going to solve this? So once they do that, just remember that you're going to have to use the quadratic formula. But to use the quadratic formula, you have to remember what is your A, what is your B, what is your C. So, okay, let me just write that. Round off to 2 decimal places. Oh, sorry about that. So once you see this, just remember that you don't have to crack your head. You're gonna have to use the quadratic formula. So there's the basic quadratic formula, and it's in your formula sheet for reference. So, and then once you have that, you just substitute this is your A. So your A is the whole 5, like positive 5, and then your B is negative 5. It's not just 5, and then your C is positive 1. Okay, let me say that again. Your A is positive 5, your B is negative 5, and then your C is positive 1. And then from there, you just substitute here. So if you substitute minus, so don't make a mistake by forgetting the minus that comes with the formula, because often if our B is negative, we tend to forget that there's negative there as well. So just be aware of that. And then we have plus or minus, and then here don't forget to put, so because now our B is negative, we have to make sure that we square everything. Unlike it can't, so these two are not the same. If we have, okay, not equal to, these are actually not the same, because here you're squaring everything, so you're squaring that negative as well, but here you're only squaring 5. So make sure if you have B as a negative, so, or rather any number that you have here, so to make sure that you don't make mistakes, even if it was just 5, make sure you square it, you use the brackets, so that when it's negative, you don't make any mistakes. Yeah, they're actually equal. And then from here, and then it's minus 4 multiplied by 5 multiplied by 1. You get this from your equation. Yes, that's your A and C, and then our A is 5, our C is 1. Yeah, and then in the denominator we have 2 that comes with the equation, so you have to make sure you remember that as well. 2 multiplied by 5, 5 is our A from there, and then from here I simplified. So I just like square 2 gives me 25, and then you say 4 times 5 is 20, plus multiplied by 1 is 20, and then you're gonna get 5, and then 5. Okay, I don't have to do that, but when you get here, because you have plus or minus, just remember you have to split this. So x is equals to 5 minus 5, 10, or x is equals to 5 plus root of 5 over 10. So remember you can't leave it here. So remember you have to round off to 2 decimal places. So you're going to have to like use the calculator and then round off to 2 decimal places. And then the next question is x squared. So now instead of having equal sign here, we have inequality sign. We have inequality sign, and this one is greater than. So our equation is x squared minus 3x minus 10 greater than 0. So we want to find the values of x so that when you substitute them back here, they're actually greater than 0. So that means they're positive. So to do that, we still, because this is quadratic, we still work it as we were doing up here in question 1.1.1. So we factorize. To factorize, we get x on both sides as first terms, in each bracket rather. And then here, remember I said you find the terms here so that when you multiply them back, you get the last term. So what are the terms, or factors rather? What are the factors of 10? So that when you multiply them back, you get negative 10. So the factors are 5 and 2. So when you multiply them back, you'll get 10. But the sign, you have to be aware of the sign as well here. So when you multiply, so there's two possibilities, but let's do it like the way we did it here. So to find the signs, we say, okay, in one bracket we have 5, x and 5, and then on another bracket you have x and 2. X and 2. So when you cross multiply, you're gonna get 5x here, and then when you cross multiply, you're gonna have 2x here. But what we're looking for in the middle is negative 3x. So to get a negative 3x, that means our bigger number is going to have to be negative, so and then our smaller number is going to be positive, so that when you add them, you get negative 3x. So that means here you're going to have negative, and then you're going to have positive here, and then when you add them, you get negative 3x. So to get negative 5x, when you do cross multiplication, that means this one has to be negative, this one has to be positive. So that is why our brackets are as they are. So you see, so, and again it solves the sign here, because now when you multiply these two, negative 5 multiplied by positive 2 gives you negative 10. I was saying there's two possibilities, because now you can also say positive 5 times multiplied by negative 2 is equal to negative 10. So you don't know which one to solve. So to solve that, we use this one. So in finding that sign and the middle term here, we also solve that one, the sign there. So from there, you go ahead and say, okay, so now don't forget here. Remember, now we're dealing with inequality sign, not equality sign. So you're gonna have to come back, keep the inequality sign. In this case, the greater than, and then that means we come back here and then okay. So each bracket is gonna be greater than 0. So now we have x minus 5 is greater than 0, or x plus 2 is greater than 0. So now, and then when you go down, you're going to have to transpose, and then you get that. So that's our first term. Even here, so one might ask, why less than all of a sudden? So everything, if you're transposing, you're going to get this. So to make things easy, if you have two signs like this, just make sure the smaller one changes the sign. But to explain why it doesn't make sense, why if we have this, let's have a number line. So both excluded. So if we say x is any value that is greater than 5, so that means any number this side is x. And then if we come again and say x is any number that is greater than negative 2, that means it's any number here. So it doesn't make sense that x is greater than 5 And then x again is less than 5, because now we're trying to solve for value, so that when you put it here, it's going to give you a value that is greater than 0. So if you want to, it doesn't make sense. So you can't have two signs following each other. They can't like point to one direction. So you have to make up your mind. So to mathematically make up your mind, we choose the sign that, so it should mathematically make sense as well. So because it's mathematics, we have to make sure that there's a proof, or it's sensible. So we can't have this. We can't at one time say x is anything that is greater than 5, and then come again and say x is anything that is less than 5. Doesn't make sense. So unless the equation was in any other way, like if it was, okay, let's not go there. So if we want it to make sense, let's take any number that is between -2 and 5. Let's say, for argument's sake, let's take 0, because 0 is greater than -2 and is less than, so we want anything here is less than 5. So we want any number that is between these two numbers. So if that's the case, we're going to have 0, we're going to have 0, and then we're going to have -10. So you can't say -10 is greater than 0, you see. So it doesn't make sense, because in reality, -10 is less than 0. So yeah, and then, so to solve for that, just remember that when you get here, when you have two signs that are facing the same direction, make sure the smaller one changes the sign. Or if we were to go to, remember there's a quadratic formula, and so that means when you solve for x, you're solving for x-intercept, and this is the positive, so it's a smiley face. So it's a smiley face. So now we're looking for a part where y is greater than 0. So that means this will be -10, and then this will be -2. That will be 5. Then yeah, it's fine. So in this case, we're gonna have to say anything that is greater than any part, any x where our graph is positive. So that means anything that is above the x-intercept, the x-axis rather. Oof. So in this case, we're gonna have to, when we're shading, it's everything here, and this side as well. Clear? So our answer, our final answer is this one. And then next question, you're solving for x still. So here we have 3 root of x, 3 multiplied by root of x is equals to x minus 4. So to make this easy, I try to get rid of the root. So to get rid of the root, you're gonna have to square it, because remember, root of x is the same as as that. So we can write it like this, or we can just like get rid of it. So to get rid in code, in air quotes, to get rid of it, we gonna have to multiply by 2. That means we're gonna square up there, multiply by 2 there. So what you do on the right, you do on the left. So we square both sides. We square this side, we square that side as well. So when you square that, you get 9, and then when you square that, there's the exact same thing I was doing here. So when you square that, you get x, which is equals to x minus 4 all squared. So here, and then now you transpose, and then when you transpose, the sign changes. So we transpose 9x, and then becomes negative 9x, and then everything is equal to 0. And then from here, we're going to have to label. So now you're going to have to break down those brackets, because now you have another term here that you're going to have to multiply out, add to other terms as well. I'm sorry. So now we're going to have 2 brackets. So this means that, so x squared minus 4x minus 4x plus 16. So now it's 8x, negative 8x there. So what I did here, was doing what's this, by inspection. So excuse me there. So that's a step that you can write there. And then we have 9x. So we multiply the bracket out so that we can add these 2 like terms, negative 8x and negative 9x. And then from there, after we get negative 17. It's not 11, it's 17. And then now after that, we have x squared minus 17x plus 16 is equal to 0. And then remember again the tip up there that I mentioned, that make sure that on one side of the equation you have 0, so you equate everything to 0. And then now we're ready to solve for x. So now we found the factors. When you find the factors, x on each bracket, and then we say, okay, what are the factors of 16 that when you multiply you get 16? So the factors is 1 and 16, 2 and 8, 4 and 4, and then 8 and 2, and then 16 and 1. So when you multiply any of those pairs, you should get 16. So one of those, so you can go around and make those, but then remember the key is that when you add or subtract any of those factors, you have to get the middle term. So in this case, we can't take 2 and 8, because when you add them, you're going to get 10. When you subtract them, you're going to get 6. You can't take 4 and 4 as well, because 4 and 4, because when you add them, you're going to get 8, and then we subtract them, you're going to get 0. So we take 16 and 1, and then so here the sign is easy, because now it's not really easy, because you're still going to have to think. So what can you multiply to get positive? It can be positive and positive, then you're going to get positive. You're going to multiply negative and negative, and then you're going to get positive. So to decide that, remember again, we use that. We don't necessarily use, but in solving this, it will help us solve the last sign, the dilemma of the last sign. So remember with this, x, and then on one side we already have 16, on the other we already have 1. So to figure out the signs, you say, okay, we have x multiplied by 16 is 16x, x multiplied by 1 is x. Yeah, just x, not x1, not 1x. Sorry about the mess. And then from here I was like, okay, what's the middle term? Middle term is negative 17x. So to get negative 17x, you have to add. To add them, you're going to get 17, but then they're both positive. So to get negative, negative there, you're going to have to multiply by negative. So that means each bracket is negative. So each bracket is negative, and voila, it solves the last term, the sign of the last term, which means it's positive. Which is positive, so that means when you say negative 16 multiplied by negative 1, you get 16 there. So again, to solve for x, you're going to have to equate each bracket to 0, and then when you do that, then you're going to get x minus 16 is equal to 0, or x minus 1 is equal to 0, and then from there, the following step is when you transpose, and then you get that x is equal to 16 or x is equal to 1. So that means when you take that 16 there and there, those two sides should be equal. And when you take 1 there, those signs should be equal. But they are not. How the hell? Because now, if you take 16 and then you put it there, and then the root of 16 is 4. 4 times 3 is 12. Cool. And then when you take 16 and you put it there, so we have 12 that side. So 16 minus 4 is 12. That's fine. But now, when you take x and you put it there, it's going to be 3 times 1 is 3. And then you take 1 again, you put it there, and then that's not 3. That's negative 3. Interesting. Very interesting. So you come back. So once that happens, that means x is only 16 because if, sorry, let me put that there. So because now if you put x in there, you don't get the value, because now 3 is not equals to negative 3. So that means x is only, therefore x is only 16. So that's the final answer, not negative 1. Because now when you put it there, it doesn't work out. So x is only 16. So you see, it helps like to keep checking such things. Yeah. So the next question. Oh, 1.2. 1.2 is, okay, here. 1.2 is solving x and y simultaneously. So that means solving them at the same time. So we have two equations here. So we have 3x minus y. Okay, let me just do this. So you have 3x minus y is equal to 2. So let's make it our first equation. And then you also have 2y plus 9xy is equal to negative 1. I hope you can see it's negative 1 there. Yeah. And then now let's make it the second equation. And then from there, it's like, okay, there are many ways you can solve this, like especially if it's just the linear equations. Okay, we only have one linear equation because this one is quadratic. So to solve this, let's have equation 3, so that whereby you take one of the equations, 1 or 2, and then you make y or x subject of the formula, but make sure that whatever you choose, it becomes easier for you. So in essence, you shouldn't make things difficult for you. Let's say for now you have, if you choose here, and then so what I try to do is like avoid fractions, because you might get they might get complicated and big, and then you lose your side there. So let's say, for instance, instead of choosing this, instead of doing the way I did it, you can also go with 3x is equals to, from equation 1, is equals to 2 plus y, and x is equals to 2 plus n. So now you're going to have to, wherever you see x here, you're going to have to multiply by, you're going to have to substitute that, not multiply, excuse me there, you're going to have to substitute with 2 plus y all over 3. It can be messy, because now you're going to have to, in this case, it's going to have to be 9 multiplied by that all squared. So you're going to have to square that before you even multiply by 9. So it's another process. So when you select your equations here, and even to get here to get to equation 3, make sure you choose the easier one. Like for instance, even if you choose this one, I'm going to transpose that, and then you're still going to have to divide here. And so a tip is avoid making huge or complicated rather situations for yourselves, because now when you're writing, you try to save time and you're panicking, or you shouldn't panic. But yeah, so to avoid panicking and making mistakes, try to keep things as simple as possible. So I chose the first one, and I made y subject of the formula. So, and then you go like, okay, substitute 3 into 2. We can't say a substitute 3 into 1, because we derived 3 from 1. So we can't do that, because that one, it won't get us anywhere. So with this method of making one subject of the formula, one variable subject of the formula, we're trying to make sure that we only have one variable, so that it's easy to solve. Like we were solve for x, like we were doing like solve for x, it was only x. And now we want to, it can be solving for, only have like one variable in terms of y, and then solve for y, and then come back and then substitute it, and then you get x. Or in this case, when you substitute y, we get only x as our variable, and then from there it becomes easy. And then so we took equation 3 and then substitute it into equation 2. So wherever we see y, like in this case, we're going to substitute with 3x minus 2. So 2 multiply, like here, 2 multiplied by 3x minus 2 plus 9x squared is equals to negative 1. So, and then from here, we multiply out the bracket. You say 2 multiplied by 3x becomes 6x. And then we say 2 multiplied by 2, negative 2x, it becomes negative 4x. So now everything is out in the open. And then if you recognize that, that's a quadratic formula. So again, the tip I was telling you about, you can't equate it, you can't come here and then say, okay, once it's here, let's open the bracket. Make sure on one side of the equation you have 0. So that is why when you got here, we transposed it. And when we transpose it, it changes the sign, it becomes positive, and then we have, remember, now we're adding the like terms. When you add the like terms, we get negative 3, because it's going to be negative 4 plus 1 becomes negative 3. And then from here, so the final thing, the final equation is 9x squared plus 6x minus 3 is equals to 0. And then once you have 0 on one side of the equation, you can solve. But before you solve, try to make things simple for yourself. So to do that, like, okay, there's a common factor here. The common factor is 3. So you can just divide by 3. everything by 3. So you say 9 divided by 3, okay, the whole term, sorry. So 9x squared divided by 3 plus 6x divided by 3 minus 3 divided by 3, and remember what you do on the left, you do on the right. And 0 divided by 3, and any number divided by 0 divided by any number is 0. And then now we have 3 here because 3 goes 3 times into 9, and then we have 2 here because 3 goes 2 times into 6, and then we have 1 here because 3 goes once into 3, and then yeah, 0. Like I said, in 0 divided by any number is 0. And then here we're back to the basic one. Again, oh here, okay, let me do it. So that means here you have 3x, and then on one side you have 1 and 1. These are our brackets. And remember now, we cross multiply, and cross multiply, so okay, x multiplied by 1, you get x. 3x multiplied by 1, you get 3x. And then on in the what's this? Our middle term is positive 2x. So to get 2x, so what you're looking for is 2x. It's like, okay, positive and negative, because now you are negative, sorry. So now when you add them, we're going to have positive because the creator number, which is 3, is positive. So when you add them, you get 2x. So now we have 2 negative x plus positive 3x. Yeah, no, I didn't have to say positive. So now you're getting 2x. So that means our sign, when you cross multiply, this one will be negative, and then when you cross multiply, this one will be positive. So yeah, and then now this is the signs for these are the signs for our brackets. So that means the first bracket is negative, then the second bracket is positive. So for instance, when you multiply them out, this one, okay, 3x multiplied by x will give you 3x squared. And then this one, you say a negative 1 multiplied by positive 1 will give you that. So the middle one, we already did it there. And then from here, once, remember now we have 0. We say, okay, what each bracket equated to 0. And then from there, it's like, okay, we equate it, and then it's like, okay, 3x minus 1 is equal to 0, or x plus 1 is equal to 0. And then from there, you simply transpose 1, and then it becomes positive, and then divide by 3, and then you get x. And then come this side, I was like, oh, simply transpose. And then you get x is equal to 1, negative 1. That's about it. Yep. Ah, the fun one. Is it? Yeah, it is the fun one. So here, normally the last question for question 1, they try to be tricky, but you simply need to use everything you've learned in maths, specifically algebra. So now, they said we have this, like 3 to the power of 9x is equal to 64, and 5 to the power of root of p is equal to 64 as well. And then they want the value of this. How do we get there? So to get there, we have to simplify things ourselves. So I would advise you, because this one is like legit tricky. So to save time, just skip it. Just make sure you leave enough space for it, because you might spend too much time on this type of questions. But once you've done anything else, and then you can come back. That's if you still have time, because it's only like 4 marks. I think it's 4 marks. Yeah, it's 4 marks. So this type of questions are legit like tricky. They're trying to trick you to see if you can like think. But remember, this is like question 1. So to save time, skip it and come back later just to save time. But if you know your stuff, do it and then get through. But advice I would give you is like, okay, skip it and then come back later. But anyway, let's do it. So this one, I love this kind of questions because that's what I'm saying, the fun ones, because now you get to think like, how did you do it? How do I do this? So now, to make things easy for ourselves, as you can see here, okay, yeah, they want everything to be like now. We have to make sure that we have x 3 to the power of x minus 1, but we don't have minus 1 there. No need to worry about that. So what we can do is like, okay, we have to make sure that we have this, because remember, the only reason we have that negative there is because remember the exponential rules. When you divide the same basis, you subtract the exponent. Or when you multiply the same basis, you add the exponent. And in this case, our exponent could be -1. So you're adding, so that the sign doesn't really change. So in this case, let's try to simplify what we have first, and then we can come back here. So what, okay, and then here as well, we have 5 to the power of root p is equals to 64. So now, look here. Here they say they want the root of 5, and we only have 5 to the power of root of p. And how do we introduce that there? We're gonna figure that out, which is quite fun as well. And now, so to get 3 to the power of 3x, 3 to the power of x, or 3x, because now if we multiply that, you're gonna get 3x. So to do that, you say, okay, let's break everything up. So how can we get 9x? So like, okay, 3 by 3, that's 9x. 3 by 3x, I mean, is 9x. So we can just take it out, because this, we haven't done anything illegal. So that means we still get that. And then on the right hand side as well, it's like, okay, because remember, we want 3 to the power of 3x, that. So now, oh yeah, so now to get rid of that, we didn't have to do this, or we could have like left it there. But to make things easy, okay, so to get rid of that, we multiply by 1/3 on each side. So that means we have 1/3. So this doesn't make sense, so you're going to have to use a calculator. So to make things easy, we say, okay, let's do that as well, because we're finding the root, the cubic root. We're finding the cubic root of 64. So that means we can write 64 as 4 to the power of 3. And then now, because that one will cancel, that one we only have 1 there, so we have that. And then on the right hand side, we do the same thing. 3 multiplied by 1/3, we get 4, because now it's to the power of 1. So we have 3x that they have there. So we sorted with that one. So to get the root of 5, it's easy as well, because now we can simply introduce the root on both sides, and then we get that. But now you might be wondering, what about the root of p, the one that is in the power there? So this one, if you know your exponent, it's easy. Let me see where I explained it. Okay, here. So remember, okay, this a to the power of b is just an exponent, like the basic exponent. And when you put the root there, this is the same as saying a to the power of everything, right? And then we can go further, say, okay, this is the same as that, all right? And now, how about we do this? Everything is still legal, so that means this gives us a to the power of b. So that means when you introduce, like here, when you introduce the root there, our b there, which is p in this case, root of p in this case, doesn't change. It's not affected at all. So I just like doing this on the side so that you can see how we got here. And then remember, now you square this side, you square that side. Whatever you do on the left, you do on the right. So yeah, and then now the root of 64 is 8. And then now we have this, and then what about that? How do we get that? This one is easy now. Everything is easy because now everything comes together. So to get there, you can't just substitute. You can't just say, okay, we have that, and then that's 4. No, it doesn't work like that. So you're gonna have to reverse the what's this? The rule that said when you multiply the same basis, you add the exponent. So before that, before we can even think of that, we can do it, but it's gonna be messy. So what we can do is like multiply out, like I did here. Okay, let me just do this and then I'll explain what's gonna be messy. You multiply out, and then comes 3x, and then 3. So everything is like 3 to the power of 3x minus 3, and then this one stays the same. So we can't do anything here. And then we come. It's like, okay, when you reverse it, it's like, okay, multiply and then you add. So that means initially we had to multiply same basis, and then we added the exponents. So that didn't change. But now we're going back. So when you go back, it's like, oh, this is what we have here. So this is what we have. So we say, okay, that's 4. And then that's a number. You don't have to worry about it. And then below here, we have this value as 8. So that means we can just substitute it. And voila. And then from here, I'm tempted. Okay, let's do it. I don't know, this is just a waste of time though, because 4 goes there. One, 3 to the power of 3 times 2. So what's 3 to the power of 3? 3 times 3 is 9, 9 times 3 is 27. So 27 times 2, 27 times 2 is 54. So 1. So that's why I was saying I'm tempted. You don't need to do that. It's just me. So you can just go straight. And that's it for today. That's question 1. Oh. And that's question 1, and I thank you very much. And I hope you enjoyed it as much as I did. Thank you.